look then at acid-base reactions, because this section's all about reactions. So we can finally get to the point where we can talk about reactions. So an acid-base reaction is exactly what it sounds like. You have an acid, something that will donate a proton, and a base, something that accepts protons or hydrogen ions. And so if you look, all of these acids have something in common. They all contain hydrogen. So acids have to contain a hydrogen because they have to be able to give up a hydrogen ion, or as I've been calling them, protons. And so then the bases, here, these guys are all hydroxides. They generally will be. There are some exceptions to that. These also are called neutralization reactions because when an acid and a base interact, they neutralize each other. So that's the idea when, for example, you have a stomach ache, of taking something like Mylanta or Tums, because your stomach ache is coming from the acid in your stomach. That Mylanta or Tums contains a base, and so they will neutralize each other when they react, and they will create two things. So you have the positive ion from the base and the negative ion from the acid are going to react. That's how they neutralize each other, and they're going to create a salt. So depending on the acid and the base that are reacting is going to determine what salt you make. And then the other thing they're going to make is water. So every single acid-base reaction is going to do this. So you're going to get an acid and a base together. When they do that, the positive ion and the negative ion are going to interact together. That's what creates the water. So if you look, here is the positive ion, here is the negative ion. That's what makes the water. What's left over, CnNa, that makes the salt. And so these acid-base reactions are important to create salts, but sometimes we also use them if, for example, we are using acids to do etching or plating or something like that, and then we need to be able to dispose of the acids. We can use bases in order to neutralize them. So the other thing that I want to mention as far as acids is acidic rain. So when we talk about acidic rain, acid rain or acidic rain is any sort of rain that has a pH lower than 5. So any pH at 5 or below is considered acidic rain. And actually here in Ohio, we do hit that pH at times. And the reason why, we have two sources for acidic rain. One, carbon dioxide levels in the atmosphere are rising. I am guessing you've heard about this. This is coming from things like us burning fossil fuels and deforestation and so forth. And so what's going on is it's the creation of an acid from that carbon dioxide in the atmosphere. So carbon dioxide, the gas, is going to interact with water in the atmosphere. And what it ends up creating is carbonic acid. So this carbonic acid is dissolved in the rain and it falls down along with everything else whenever it rains. But it's not the only problem. We also, when we burn coal and oil, release sulfur compounds, SO2. Sulfur dioxide is one of the big ones. And here's the set of reactions, if you're curious on how it works. So it combines with oxygen in the atmosphere to create sulfate. Then that sulfate reacts with water, just like the carbon dioxide, and it creates sulfuric acid. And I'm guessing you've heard of sulfuric acid. That one's fairly nasty. And so these reactions are going to create carbonic acid and sulfuric acid that are going to be in the precipitation that falls down. And you might be thinking, so what? I don't care. Well, the thing is that this actually has been creating quite a bit of damage. And so it damages different types of buildings and monuments and artworks. So this is actually in New York, I believe it's in Central Park. This is what it looked like when it was installed. So you can see all kinds of carvings and so forth on the monument. This is what it looks like today. Extremely discolored, but also the carvings aren't very sharp anymore. And this is because the material it's made out of is being dissolved by this acid rain. So the materials that we generally have been building with in the past are things like limestone, sandstone, marble, and these are made out of basic materials. They have things like carbonate in them. And when the acid, the carbonic acid and the sulfuric acid hit these monuments, they react and create these salts and so forth, but they dissolve away the structure of these buildings and monuments. If you ever get a chance to go down to the State House, the Capitol in Columbus, you can actually see this. You can find fossils in the steps and walls now that were not originally there because that area is built out of limestone. And that's another one that's got those same sort of compounds in it. And over time, the rock has just been eaten away by the acid rain. It's also a problem for living organisms. So these numbers for the pH, these critical pH levels, these organisms cannot survive below these pH levels. And so this is going to be a problem. If our waterways drop below these pH levels, the adults might be able to survive, but the problem is for a lot of these guys is that their larvae can't survive or the eggs can't survive. And so we need to be able to keep some of this into control. All right, I've got two other reactions to talk about. So acid bases, you can run into that one depending on what you might be working on. Corrosion, this is another one that affects us in our daily lives and also could affect art pieces if you're working on installations outside. So corrosion is the process where metal deteriorates through what we call oxidation reduction reactions. So what you're seeing here are a whole bunch of these types of oxidation reduction reactions. So the main one that you're seeing like here, this is the reaction with iron. So iron combined with oxygen and water over time is going to create iron oxide, aka rust, plus water. And it creates a new material. So remember, that is a chemical change. That is not something we can undo. You get the same sort of thing with zinc or steel. I believe this is actually zinc. So you get a patina type material on the outside of it. You've got the same thing on the propeller here, and you get it on copper. Copper, when it's exposed to acids, so this is why you get this coloring on statues. You get it exposed to that acid type condition and it will have the corrosion reaction and start actually eating away at the copper metal. You can actually prevent corrosion by coating metal with zinc. And so that zinc is going to oxidize first and keep the metal underneath protected. This is what we do with a lot of our bridges and so forth. So we'll actually coat the steel and so forth with a zinc coating. And so that will actually oxidize before the steel underneath and help protect it. Often we then actually put even a coating of paint over top of that. to give that extra layer of protection against this corrosion process. Because most of our metals will undergo the corrosion process with these oxidation reduction reactions, where they don't always have to interact with oxygen, but often do, to create these new materials that are generally not as beneficial for what we're trying to do. The last one, so we talked corrosion, now combustion. Combustion is another oxidation reduction reaction. So again, very often does involve oxygen. But here, what we're doing is applying heat, and it is a reaction between a non-metallic material and oxygen. So corrosion, this one is going to happen between a metal and generally oxygen or another material to create that new material. Combustion reactions is an oxidation reaction between a non-metallic material and oxygen to create new materials. So for example, here's our methane reaction again. So methane is a non-metallic material. Oxygen plus methane plus a little bit of heat, like a spark, and you're going to get a lot of heat, hence you can see around that reaction arrow, a lot of heat, and that's going to make carbon dioxide and water. Other combustion reactions that you're familiar with, I mean, pretty much any gas reaction. So you've got, torches, things like that for propane and welding torches. These are all going to work on combustion. And then you can see there like wood. Wood is going to be a combustion reaction if you're going to expose it to heat. That will allow the combustion reaction to proceed and produce lots of heat and new materials like carbon dioxide, water, and ash. So that's the end of chemical reactions. So I'm going to head out.